All right, first thing we want to cover is how to reduce radicals. We run into it with the distance formula, Pythagorean theorem, and we want to be able to reduce them. And so I want you to be thinking in your head about all these perfect squares, things that we can take the square root of and get a nice answer. Like the square root of 9 is 3, square root of 36 is 6, square root of 64 is 8. And so these are factors that we're going to be looking for. So when we look at 200, do any of these numbers go into 200? And you want to look for the biggest one. And so maybe you spot 4 right away, and you think, okay, well, 200 divided by 4 is what? Is 50. But within 50, there's another factor of 25. And so that's why we want to find the biggest one. And 100 goes into 200. So I'm going to rewrite this as 100 times 2, square root of 100 times square root of 2, and the square root of 100 becomes 10. Square root of 2, I don't know what it is, so it just stays as it is, and that's how we reduce it. If you're ever curious about if you wrote it right at the end, you can compare square root of 10 square root 10 to square root of 200, and you should get the same decimal. This won't tell you if you've reduced it fully, but otherwise. So then 68, you may have a little harder time figuring out, but if you can think through, let's just start dividing. Hey, it's an even number. I wonder if it's divisible by 4. And sure enough, 4 times 17 is 68, so I can change this. Square root of 4 is 2, and so 2 root 17 is my final answer. 96. 96 might be a little harder. Sometimes if I just divide by 4 again because I see the even number, but then I see there's another multiple of 4. And so ultimately I can divide by 4 again, so that means 94 divided by 4 times 4 is going to give, so, sorry, 96 divided by 4 times 4. So I get 16 times 6. So 16 times 6, square root of 16 times the square root of 6, so I get 4 root 6. Now sometimes you might get a problem of what if I don't see it right away? And let's say that we do 96 divided by 4, and we say 4 times 24. And so instead of finding the 16, which is the biggest one, I find the 4, and I reduce it to 2 square root 24. Well, then I want you to look at 24 and say, have I factored out all of the perfect squares? Well, 24 is 4 times 6. And so I can take the square root of 4 and get 2, and then get the square root of 6 at the end. So the square root of 4 became the 2. 2 times 2 is 4, and 4 root 6 is what we're looking for. And that's how we reduce radicals. And so any time you run into radicals that we want to be in reduced radical form, this is what we're talking about.